In this video, I'll introduce you to random variables with a focus on discrete random variables in particular. So first we need to talk about what a random variable is in the first place. It's a numerical description of the result of an experiment. It's typically denoted by a capital letter, such as uppercase X. It's discrete if its possible values can be enumerated. We can list them out in some orderly fashion. So it could be taking on a finite number of possible values or a countably infinite number of possible values. X is continuous if it can take on any value in an interval. And we'll, after some examples, kind of set that aside for the next topic. We will focus here on the PMF and CDF of a discrete random variable. So the PMF is a probability mass function. It describes probabilities like the probability that our random variable is equal to 3, equal to some particular value. This is an example of a probability mass. A CDF, so the PMF is denoted lowercase f of x. A CDF is denoted uppercase f of x, and it describes what are called cumulative probabilities. So this is a cumulative probability. The probability x is less than or equal to 3. Okay. All right, and then we'll come back to the rest of the stuff, later in the slides and other videos. Here's a bunch of examples. So again, a random variable is technically a numerical description of the result of an experiment. So every one of these examples comes with an experiment first. Toss a coin 5 times. Maybe X counts the number of heads. That's discrete. It could be 0, 1, 2, 3, 4, or 5. Okay. Another experiment that you've seen, toss 2 4-sided dice. The sum of the dice, that's a random variable. Okay. The maximum of the dice, that's also a random variable. So an experiment can have many, many different random variables that describe different things about the outcome numerically. All right, both of those are discrete variables. You could list out the finite possibilities in each case. Here's a very different one. Draw 2 numbers, x and y, randomly and independently from the 0, 1 interval, sort of non-inclusive of 0 and 1. Okay. So x and y are continuous random variables, and we could also, define a bunch of other random variables. So let v be just whether x is greater than y. 1 if yes, 0 if no. That's a discrete variable. Let w be the difference between x and y. That's continuous. Let z be the ratio of them. That's also continuous. All right. Stretching the definition of an experiment just a little bit, think about the performance of the U.S. economy over the next year. This is, we can think of as random in the sense that we, can't perfectly forecast it. Okay. The percent change in real GDP over the next year can take on any value in some reasonable interval, so that's continuous. The number of months over the next year that the U.S. economy is in recession is discrete, integers 0 through 12. Another experiment, this is sort of thinking well ahead to when we come back to the idea of sampling variability later in the course. Sample a U.S. worker at random, right? There's many different things we could learn about this worker. One of them would be like their annual salary. That's continuous on some interval. Another would be whether they have a college degree. 1 if yes, 0 if no. That's a discrete variable. Okay, let's look at probability mass functions, or PMFs. Again, denoted lowercase f, and it describes a point-wise probability. So for example, if we say little f of 3, for a discrete random variable x, we mean the probability x is equal to 3. All right? It has to be the case. So for a discrete random variable, a PMF value is a probability. It's a particular probability. So it has to obey all the rules of probability, including that each probability has to be non-negative, and that if you add up the probabilities across all the possible x, you should get a total probability of 1. Okay, here's an example that we will look at. A relatively simple example, without being totally trivial, is tossing a coin twice, and let random variable x be the number of heads that we get. Okay, so formally speaking, a random variable is a mapping from elements of the sample space, that is from sort of the set of potential outcomes, to the real numbers. Okay, so there are 4 equally likely outcomes in this experiment: heads heads, heads tails, tails heads, or tails tails. And then x is 2 1 or 0, depending on exactly what happens. Okay, we can get 2 heads, we get 0 heads, or there's 2 different ways to get exactly 1 of the coins to be heads. All right, so these things are equally likely. 1/4 probability attaches to each of them. All right, so the probability that x is 0 is 1/4, and the probability x is 2 is 1/4, but the probability x is 1 is 2/4 or 1/2. Right? This table is a way of writing that PMF of x. It attaches to every possible value of x, 0, 1, or 2, a probability. And those have to, again, obey all the rules of probability. This is another way, the sort of case-wise representation. The probability is 1/4 for these 2 values of x, 1/2 for this value of x, and then 0 otherwise is often written. I tend to think the table is easier to think about, but this is, a version you'll see sometimes too. All right. Just again, to sort of hammer on the notation here. If we say for a discrete variable, we're looking at little f of 1. That is just notation for the probability that x is equal to 1, which we have seen is 1/2. Okay, last thing for this video is the CDF, the cumulative distribution function. So remember that from that first slide, it's denoted capital F, and it's a cumulative probability. And so we find that probability by adding up the probabilities of all the possible values that are less than or equal to x, right? And because we're sort of being formal about that, the generic, so we have a value x in mind, like 2, okay? So that's fixed here, and then we're going to let the generic be some other letter y, okay? But when you see this written out, it's, hopefully will strike you as very simple. So if I want to know capital F of 1, the CDF value when x is 1, that is itself just notation for the probability x is less than or equal to 1. All right, so what can happen for x to be less than or equal to 1 in this running example that we have? Well, x could be 0, or x could be 1. All right, so in this case right here, the little x is 1, and the y is just tracing all the different possible values less than or equal to 1. Okay, that's all that it means. We have seen the probability x is 0 is 1/4, the probability x is 1 is 1/2, and so the CDF value is 3/4. There's a 3 in 4 chance that x will be less than or equal to 1. So that's the PMF and the CDF for discrete variables.